from your perspective, it might be a little hard to gauge the arrangement of the trees here, but I can tell you that we're in a stand that's very dense. It's very shaded. If we look up at the canopy, we have strong canopy closure. But you also notice we have lots of trees here, and they're relatively small. And you can probably see behind us lots of downed wood, lots of small trees that have fallen. And if you were to look up, you'll also notice that a lot of these trees are dead or in decline, and they also tend to have relatively small live crowns. They don't have much space to spread out, and they also, the bole, or the crown of the tree, is relatively short on the trunk. And so all of those things together tell us that we are in the stem exclusion phase of stand development in this stand, and we're seeing self-thinning in action. So when these trees were younger and smaller, there was enough resources for all of them, particularly light, and as they've continued to grow, now their energy requirements are larger as bigger trees, and they're very crowded in. So now we don't have enough resources for all of these trees to survive, so we're having density-dependent mortality. So there's lots of mortality in here, there's lots of snags and trees that are declining, but it's not due to disease or fungus or insects. It's due to just simply to those trees not being able to have enough resources in order to survive. Cheryl, can you talk a little bit about perhaps why this stand might not have been thinned? Because when you have density-dependent mortality in the stem exclusion phase, thinning, and in this case maybe it would be a pre-commercial thinning, or perhaps there would be market for this, would be one way to kind of help the stand kind of jump forward past this stage in development.
That's right. It could, and get us to our sort of final goals more quickly. And actually, the thinnings here would be viable from a commercial standpoint. So even these small cedar, they have actually a really good value, and this is a stand that's quite high in cedar. So altogether, the cedar, there's fir, there's hemlock. It's quite dense. This is good timing in the development of the stand at this kind of self-thinning stage to come along and do a thinning. Mm-hmm. There's just a wave of thinning that's going to happen anyway. And so really what you're doing is you're salvaging some of that mortality just as it happens or just before it happens, and doing a treatment that increases the value of the stand at the same time. But why didn't we thin here? A few different reasons. First of all, because our primary goal here is to have a variety of sites for research and education, it's part of our management planning to not treat everything the same way, and we definitely need untreated areas. They're important control areas for research trials to have completely untreated, untouched areas. And they're really helpful for education so that you get to see what this stand would have looked like, sort of before thinning or without any thinning. There's a couple of other reasons why this is not an ideal candidate anyway. Although the stand itself is great, we're on a relatively steep slope. So this is too steep for a ground-based thinning. So we would have to use a cable system here that. When you say
cable system to remove the trees after they're cut?
Right, so you'd need to use, like a skyline type of a cable system, something like that. It's more expensive, that kind of a harvesting system. So the economics of a commercial thinning here are not as good, and in fact, it's really not economically feasible most of the time here. And another thing on top of that steeper slope here and the need for a more expensive equipment to log it is that it's not a very big unit. So you don't get to see that from where you are, but just down below us at the toe of this slope, there's actually a fish-bearing stream flowing by. And it's just kind of a narrow, small area. So we wouldn't want to disturb that stream. We would be leaving a riparian buffer on it, and so it's just not a very large unit either. It doesn't make it very economically viable, so it's a good one to leave untouched and unmanaged for education and research purposes.
And maybe shifting away from a timber perspective, from an ecological perspective, we talked about in an area that had been thinned or had been harvested, and we have a big flush of undergrowth, which can be very useful for some species. Are there some, from an ecological perspective, might there be some advantages to keeping some stands in an unthinned state and letting them kind of more slowly progress through the stem exclusion phase?
Sure, absolutely. I think so. I mean, I'm not a wildlife expert, but you see very little understory here. Right now, just about everything is shaded out, except for a few of the really, very shade tolerant mosses. That's one of the ones that you do typically see on the forest floor of a very, very dense conifer stand. And you just get a few other very small plants. So, from that perspective, for, animals that forage, for example, no, it's not a great place for them. But there are other animals, other species of, birds and mammals and insects and such that are benefiting from this slow thinning process in a very dense stand. For example, all of these, small dead standing trees, and even some of the larger ones that are going to lose in this competition. I mean, those are going to be really great for insects and just different kinds of decay organisms and all of the rest of the food chain that depends on them. So woodpeckers, for example, and birds that require a variety of insects, that sort of thing.
I would imagine that the snags are probably not quite big enough to support, or most of these are not quite big enough to support cavity nesting birds, but they'll still support the insects that woodpeckers and other birds
They're great for foraging.
Will forage on as this wood decays and insects come into it.
Yeah, and there are species that thrive in really dense stands. Like they really need that cover and that space to hide, and they're just really well adapted to moving around in really dense stands.
So if this was a stand that you weren't trying to maintain in this state for research purposes, and maybe it wasn't so steep, would you? Are we a little bit past the point, just looking around and seeing the level of mortality, do you think we're kind of past an ideal point for thinning this, or where do we fall in the range?
I mean, there would be definitely have been benefits to doing this maybe 10 years previous, but you haven't lost the window of opportunity here. This is the self-thinning phase. It's a relatively slow process on a kind of a mid-slope like this. It takes time, and these are, again, very long-lived trees. So these cedars that we're standing beside, for example, there's still lots of growth potential in them if they were to be thinned, like even now or even 10 years from now. We found that they respond really well. So
they have enough plasticity still that you would expect to have a nice, good growth response to that thinning if you were to decide.
Yeah, I mean, if we were in a different part of the world where the whole growth trajectory is much more quick, that would be a different thing. But we're not. Things take a longer time here, and especially on a site like this that's just, sort of a mesec or medium site. Things are not moving that quickly. And, you got to look when you decide whether you're going to, sort of treat an area and focus on it or not. You need to look at your whole forest area and, you don't want to do the exact same thing on every hectare by any means. We don't have an economic driving need to maximize the dollar value of every hectare either, because there are these research and education objectives. So you just need to know, if non-timber objectives are a factor, and they often are, then there may be lots of good reasons to leave certain areas alone. And when you are going to invest in silviculture, to focus on the ones that are going to be the most, productive and are going to give you the greatest return for the investment.
Yeah, so something like this, it would be very expensive to thin, and so you would not the cost related to the benefit of that thinning would be different than in an area where it would be very easy to get into thin.
Right, and we've got enough forest here that we can do a number of different treatments here and manage some areas more for non-timber values.